Okay, for the group projects, okay, on the first discussion, for the group, hopefully we will start on this week. We will start on this week. Start with a few group. Okay, we post later on. Maybe maybe three slot, 3 to 4 slot per group per day. So Monday. Okay, so Tuesday, Wednesday. Okay, or maybe Thursday. Okay, 3 to 4 slot per group. Okay, so all right. What I want every group in during this group discussion. Okay, so if you refer to the example of the project, one of the important in the group project is to determine the power required. Okay, so definitely in your projects, okay, every group, no matter sugarcane machine, trampoline machine, or what is the other one?
Fan. Ceiling fan.
Huh?
Ceiling fan.
Ceiling fan. Okay, ceiling fan. Every of the project need power. Definitely need power. Motor lah. Need motor. Power. Okay. Need motor power. So this is the first thing in your project to determine what is the power required in your project. So uh, okay, power required. So okay, first, okay, you need to know the theory to calculate power. This first thing you have to know. Theory to calculate power. Okay, theory to calculate power. Definitely, it require some basic information, which is weight for the case of this escalator. Okay, example of this escalator. The
Doktor,
important is
sekarang
sorry. Uh,
Doktor tak ada present.
Alright, sorry. Okay, so I repeat again. In every group, the important is to determine power. What is the power required? Either you work on a ceiling fan, or you focus group on the sugarcane machine, or you work on the third one in trampoline machine. Okay, so you need power. You need power. So first thing, each of the group need to find what is the theory to calculate the power. So based on their project, then you have to uh, find the theory, and then the second thing is get the information info, input info or input. Okay, let's say input parameter. Input parameter. Okay, input parameters to define, to determine what is the required power. Eh? For the case some, okay, maybe for the ceiling fan, for the ceiling fan, for example, for ceiling fan, maybe one of the criteria, okay, you have to know what is the speed, eh? Speed, from speed, speed of span, speed. What is the speed you want to set? Eh? What is the mass? From that, then you can determine what is the power required, power required, and then okay, in this case, let's say in this, for example, escalator, escalator, okay, is involve total weight of the stairs, total weight of the passengers, okay, and then what is the velocity, speed, eh? So from this theory, they got the minimum power, 9.8 kilometer. Similar to this, let's say, what is the speed, what is the m, and then you get the you got some parameter to find the power, similar to the, let's say, for SM. Sugarcane, let's say, what is the speed, what is the speed, what is the torque, maybe, torque, speed, okay. And then for trombone machine, maybe is one of the parameter is what is the mass, okay. So for ceiling fan, of course, you have to know the speed, the m, and then the size, from size. Okay, ceiling fan, I want to know the focus, okay, means that for ceiling fan, you have to know where, the idea is where to install, okay, where to install, okay. Okay, for example, if you want to install a factory, what is the size of factory? Okay, from that factory, and then you can determine what is the length of the blade, the length of the blade, how many length. From there you can get ideas. What is the m, the mass? What is the mass? Okay. So far, ceiling fan. Any question? Okay. So one of the idea is let's say for factory, to use in the factory, maybe let's say, what else? We have to think about where to install the ideas. The ideas. Imagine you are a small company, focusing to install the ceiling fan. You ask the customer, okay, what is the size of factory? Contoh, for example. From that, you can determine what is the length. From the length, you can know what is the mass. From that, you can then what is the speed required you want to set. Okay. From there, you can get from the theory, you get the minimum power. Minimum. You can get the minimum power required from the calculation. Okay. Factory, maybe another example, maybe you want to in the mosque, okay, MOS, in the mosque, and then maybe a school, school hall, school hall. You imagine where to install. That's your group. All right. For second, for sugarcane machine, you have to know, okay, a diameter of the, maybe a diameter of the, what we call it, tebu apa English,
Sugar cane, doctor.
sugarcane lah ya. Okay, what is the diameter of the sugarcane, diameter, and then from your study, do some literature review, study what is the minimum required of the top so that you can press, get the theory first to calculate, then get some information, and then you design based on your design, how many let's say opening diameter, in one shot, how many sugarcane you want to put inside together, calculate based on your design, customer design. Imagine some logic story, then from there you got the input parameter, and then from there using the theory calculation you get the minimum power. Similar then to the tremor machine. Okay, what is the purpose of your tremor machine? Okay, what is the purpose? Is it for food? Is it for food separating? Is it for uh, mining? Okay, or others? Okay. From this product, from this focus of your operating material, you can get what is the minimum, what is the mass, by defining what is the area of your machine. You get some ideas how big. Okay, let's say food, maybe let's say the cylinder maybe required only, do some research. Every group, ceiling fan, sugarcane machine, tremor machine, you need to at least minimum three, at least three minimum existing product to compare, get some literature review. From there you get some ideas. Let's say for food mining, let's say you want to separate separate um, separate maybe shell. Okay. Okay. From here, okay, some idea. They said, okay, shell, a muscle, a vibration. See this kind of information. Get some ideas about existing product. Okay, this one coconut shell. Okay, get some ideas. What is the size? Okay, this one. Okay, what is the size? What is the drum diameter? From there you can get some ideas about the capacity. Okay, capacity. What is this? This is a coconut. Okay, one coconut shell is the, you estimate what is the weight, and then from the volume, let's say running, let's say quarter, time volume, time mass, you can get estimate total weight. From there, using the some theory, you can get finally you can get the minimum power. Okay, so from the minimum power, the last one, at least this three step, at least three 1 2 3, from the minimum power. Okay, you know the minimum power, and then you go to catalog, find the catalog for power, for motor power, and then you choose what is the power you want to use. For example, okay, for this group, do from their calculation. Okay, minimum power required. Minimum power required for escalator is 9.8 kilowatt. 9.8 kilowatt. Therefore, then they got some find some catalog. Okay, catalog. Okay, so catalog. So they choose. Okay. Okay. They choose must higher than minimum lah. So in this case, I don't know what brand is this. Okay, the also Tech Top Australia Motor. So they select 11 kilowatt as their okay. Okay, let's say minimum they do from calculation just now. Minimum is 9 kilowatt minimum. Okay, so from catalog they select, they choose 11 kilowatt. Okay, so this what I want at least from this first discussion on the group project. Okay, 1, 2, 3. That's it. Enough. Okay. All right. So far, any question regarding this issue on the group? Okay.
Doktor,
Yes.
untuk yang part tu calculation perlu juga ke?
Calculation. What kind? Yeah.
Calculation untuk power tu nanti.
Yes. Because is of course I will ask you. Basically, okay. Let's say you have the equation. You have the equation. You have the theory. Theory calculation. From that, I will ask you how you judge your total mass is, let's say 90 kilogram. How you get this 90 kilogram? Then you need to explain. Okay, 90 kilogram is from our design. So we want to design the diameter of this trommel machine. Let's say 1 meter diameter. Okay, the volume we estimate from okay, the volume, let's say 1/4 from the overall from the volume. So one shell we estimate. Okay, you calculate lah based on your calculation. Is there logic or not? And then you compare, and then from your calculation, okay, then you find your design. You got okay your mass. Just now I mentioned about literature review. Okay, to find the power, you have the this one 3 minimum literature review. 3 minimum literature review means that's at least you have 3 existing product. From that product, and then you can compare. Is it logic or not? Is it logic or not? Let's say one diameter shell from your calculation 90 kilogram. Maybe running quarter, the overall volume. This machine 2 meter size, estimate quarter also, maybe double lah. Let's say double 90, maybe close to 150 kg. More or less look logic in terms of when we compare. Okay, then satisfied on my side and on your side. But if you compare, you got 90 kg, but this machine actually twice, but actually the mass is about let's say 20 kg. Well, something wrong. Okay, then you compare to second product, third product. See, is it logic or not? Comparison. Okay, get some ideas. Any more? So if I hope you're able to start something, discussion in the project, and then during the group project discussion, I will see the progress on your starting.
When will be the group discussion, Doctor?
Okay, I will post later in the WhatsApp. Okay, time and slot for specific group. If is it available based on the time or not? Maybe we will start on tomorrow. Maybe. Any more? Okay. So I hope I able to explain some ideas. What to do in the first step for your group project. Okay. Now we proceed with the chapter 7. Chapter 7. Chapter 7. Week 10. Is it week 10? Now is week 9. We are in week 9. Week 10. Come.
Week 9.
Week 9, sir.
Week 9, but I check on the RTP. Okay, week 9, bearing. Okay, it's correct. I think it's the old, it's the old note. No worries. Okay, bearing. Okay, bearing, bearing. Bearing. Okay, bearing. All right, bearing. Okay. Okay, so again, get some ideas. Okay. Last week we talked about shaft. Okay, we talked about shaft. Okay. So maybe this standard without shoulder shaft. Okay, so there will be a bearing. In the logic, there will be in the shaft in our design project. After we select shaft, we know the diameter, and then the next is we need to define what is the suitable bearing size. Okay. Bearing. Okay. Okay. Before that, we have to understand some basic about type of bearing. Uh, Symbol in bearing nomenclature. Okay, and then the third one is calculation. The third one is calculation. Okay, bearing types. Okay, the next subtopics: bearing type, bearing mounting, bearing life, bearing load life, relating load life reliability, and then on the calculation, we need to know what happened in the existing of a radial and thrust load. Okay, in our calculation, and then finally some issue on the importance of lubrication and some appendix relating to bearing. All right, very simple. Bearings acting as support and allow rotation and sliding motion. Okay, two type of bearing: sliding and rolling. Okay, sliding friction is the take place. Okay, sliding reduce sliding friction can be reduced by using smooth machine surface and lubrication. Okay, so this is more information. Okay, next page. Okay, Okay, let familiar with some brand, famous bearing manufacturer. Okay, I think most of us well known about SKF. It's a Sweden company. That's one of the top producer of bearing, SKF. Okay, and then second is from Japan company NTN. NTN, maybe yeah, maybe I'm not sure. I think most some bearing in motor, motorcycle using some NTN brand. Okay, less well known. I think for us, similar to me, Tim Ken brand is produced by US company. Okay, the purpose. Okay, the calculation of the bearing is designed to take the pure radial load, pure axial load, or combination of both load. Okay. So bearing today all machine use this bearing in vehicle engine, shaft, fan, bicycle, and many more. Okay, standard. Okay, they use bearing standard. Use ISO, international ISO standard, and ABMA, American Bearing Manufacturing Association. Okay, next. Okay, so about bearing, we have to know. Important is outside diameter and internal diameter. OD or ID. Bore. Okay, if we have if we refer to the catalog. Okay. Bearing. Bearing analysis. Okay. 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 This is one of the. Okay. Sorry, cannot get the something wrong with this. SKF bearing catalog. Bearing catalog. Alright. Okay. Sorry, too small maybe. Okay, never mind. Later on, I show you. Okay. Okay, for essential part in bearing, outer ring, inner ring, ID, OD. This is the ball or rolling element and separator. Okay. Okay, type of ball bearings we have. Many type of bearing. So one of is a ball bearing, ball bearing type. So we have deep groove, shielded, angular, and so on. The second one we have a roller bearing. Just now ball bearing. Now it's a roller bearing. Okay, so if you refer to the your notes, okay, star, 4 star, 5 star. Okay, for let's say the first one, deep groove ball bearing. Okay, I think suitable for high speed, high rotating accuracy. Third star. Low friction, 4 star. Most common use is deep groove ball bearing or angular contact ball bearing lah. Give you 4 5 star in most of condition, high speed and low noise vibration. Okay. Okay, this type of mounting, yeah. Okay, how we going to mounting this ball bearing? Okay, some ideas. Okay, that's just now about just now is about chapter 7, bearing. Okay, chapter bearing. Just now I'm talking about types of bearing. Types can be ball, this can be roller. Okay, let's. Okay, second, I'm going to talk about number 2. Okay, it's about it's about equation. Equation in related to bearing. Okay. 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 This is basic equation to find the bearing. To find the how we going to select equation to select suitable bearing. Equation to select suitable bearing. Okay. So this one, okay. To select the equation, select suitable bearing is by calculating what is the C10 value. By calculating what is the C10 value. So C10 equal to AF FD, the one LD ND 60 over LR and R 60. Okay. So the explanation LD is on the LD is on the right one. Everything desire. Application factor is about desire. What is the desire radial load? What is the desire life? What is desire speed? Desire is referred to what is our setting, what we want. Desire means that. Okay, desire means desire. Okay, desire is customer requirement. Customer requirement. Then R is from the catalog. So L referring to life. Okay, rating life and speed RPM. Okay. Life number of revolution. Okay, this symbol is calling as number of life, number of revolution. Okay, number of revolution. So if you turn back, okay, so therefore, okay, A is depend to type of bearing, either ball bearing or roller bearing. Okay, and C10, okay, C10 we call as a catalog load rating. Catalog load rating. Okay, so that's why to find the suitable bearing, to find the suitable bearing, in your project, we have to know what is the value of C10 in our calculation. So if you turn back to the previous page, is mentioned about bearing life. Bearing life. So what we talk about C10 just now. Okay, C10 is a load rating, catalog load rating. Okay, catalog load rating. Okay, this is meaning is determined by ABMA. Okay, number of revolution at 90% of group bearing will achieve or exceed before failure. Minimum life, bearing life. So from this some definition, so agree that to find the load rating for the bearing is using this equation. Okay, using this equation. Okay, that's one point number two. Point number two in the bearing chapter. Okay, as usual, okay, we do some exercise to get more understanding. Okay. Or basically we can, okay, see this example. Okay. All right. Okay, example number one. Example 7.1. Okay. Consider SKF rating bearing 1 million. Okay, in our case, we want to know what is the catalog rating. Catalog rating, if you want to select the bearing. Okay, so we use the basic equation. C10 just now, C10 AFD LD over LR. All right. Okay. The question is, okay. Our desire life, we put 5,000 hours. Okay. Okay. Desire life 5,000. Okay. Desire life. In this case, okay. Desire life. Desire life. What is desire life? Is the LD. Desire life LD. Okay. LD. In our case, ILD 5,000 hours. Okay. So it's reflect in your project. Okay. What does it mean of 5,000 hours? Okay. What does it mean of your setting desired life? 5,000 hours. So means that basic calculation is, let's say, okay, let's say your machine running one day. One day, let's say running 10 hours. Okay, let's say running, okay, masuk kerja pukul berapa? 8. Okay, 9 start running 9, 10, 11, 12, 1, 2, 3, 4. Okay, 4. Okay, 4, 7. Okay, for 9, let's say 9 a.m. to 4 p.m. It's about 7 hours. 7 hours running one day. Okay, one day, 1 month operating about 1 month. 5 kali 4, 20. Seminggu, let's say 1 week 5 days. 5 kali 4, 20. 25 times 7 sebulan. Okay, so running about 140 hours. Okay, that is for one month. Okay, 12 month, 1 year. Okay, so 140 hours time 12. Okay, berapa ni? 1680. Someone want to coming? Okay. Okay, 1680. Alright. Okay, that's required hours in a year. Okay, a year. A year. So let's say you time, let's say 5. Berapa?
8,400.
8,000 8 k hours. Okay. So you setting 5,000 hours. So let's say time 4. Sorry, time 3. Time 3. 5,040. Okay. Okay, ngam soy ya. Okay, so means that you setting this what you mean of desire life. Desire life, you as usual, you set 5,000 hours. So you estimate that this bearing is running. If you operate one day about 7 hours, okay, it will last long until up to 3 years, roughly, 3 years. But if this machine running two shift, maybe within 1.5 hours, you need to replace. That's what we setting. This what we call as desire life. You as a user, this is what is mean of desire life just now. Desire life, 5,000 hours. Okay, and then revolution, revolution speed 1725. Okay, revolution per minute. Okay, this is considered as also desire. As a user, you setting what is the speed. What is the speed? Okay. Okay, then from your calculation, the load acting is 2 kilonewton. The load that acting is 2 kilonewton. There will be a load, definitely, on the shaft. There will be some bearing, or there will be a gear. From gear, there will be a load. Definitely, there will be a load. Some load there. We define the RPM, and we setting the desired life. So this is information. This is the information that we should know. This one, desired speed, desired life, desired load, based on our design. Okay. Okay. Then okay, reliability. We set the reliability lah. Reliability. Okay. So from this equation calculation, okay, we use ball bearing. That's why I select two, ball bearing. Sorry, application factor. Application factor. Application factor. Issue one is not given. Application factor. Okay. Is there any? Okay. Okay. In this example, it's not given. So assume A equal to 1. If not given. Okay. And then that's why desired load is 2 kilonewton. 2, and then we put all those desire life 5,000, desire speed 1725, okay, and then 60, okay, 1 over A. Okay, A is a ball bearing, that's why 1 over 3. Okay, and then what does it mean of this one? LR and R60. LR and R60. Number of revolution. Okay. Why we put this 1 million? Okay. Why 1 million? Okay, why 1 million? Okay, for type of SKF. Okay, this is very important to understand. For the type of SKF bearing, So, okay, they running, they do a setting, they're running their bearing, testing at 1 million revolution. Okay, for the case of SKF, they are testing at 1 million revolution. That's why we put here 1 million. The LRNR60. LRNR60 is number of revolution. Life. L10. L10. Minimum life. Minimum life. Okay. Is the used by most manufacturer. In the case of SKF, they use 1 million. 1 million. That's why LR and R60, the bottom one. For the case SKF bearing, they use 1 million. Okay, but if we select Timken as US, they use 90 million. So this one need to change lah, not 1 million, 90 million. Okay, so at the end you get the catalog rating. 16.5 kilonewton. 16.5 kilonewton. Okay. 16.5 kilonewton. So I need to find the catalog. Okay, this is example of catalog. Catalog. Okay, this is an example of SKF catalog. Yeah, maybe. Okay, so okay, just now we calculate that C10. C10. So if you refer to catalog for which catalog routing is in SKF catalog, okay. If you refer to the SKF catalog, okay. If you refer to the basic load rating, okay, you can find the value of CO and C. C is referring to the value of C10. Value of C10. Value of C10. Okay. So in this case, 16.05 kilonewton. Okay. For this group, okay, they calculate that the bearing C10, okay, from their project, okay, uh, 75, C10 75.91 kilonewton. There, so this is the value from the calculate. So in the catalog, they need to find the value that bigger than this one, 75. So therefore, in this group, okay, they select, okay, this is C, is as I mentioned just now, referring to C10. Okay, that's why they select 93 kilonewton. Okay. Hello? Hello? Sorry, interrupt some coming call. Okay, mana tadi ya? Okay, alright. Therefore, we refer to, okay, this is from the calculation. C10 is the load rating of the bearing. Okay, this is a minimum. So you need to select, in this case, the lowest 62 kilonewton. Okay, therefore, we need to select in this group, they select 93 is close, close to 75, but bigger is 93 kilonewton. That's how we determine the bearing. Determine the bearing. Okay, I hope clear. Okay, so let's settle about equation to select bearing. Select bearing. Give you some important about this calculation. Okay, the issue similar to test one, similar to your test or similar in your project is how you going to define this load. How you find this load. This is another issue. I think this is the one of the important. Okay. Uh, how we select 5,000 is not a big deal, but by doing some logic calculation, hours, desired life, desired speed. The issue is load, because to find the load, desired load is based on the problem, Okay. So again, is reflect on your fundamental of solid mechanic, means that how to find the proper load, how to find the proper load is based on the free body diagram and so on. If you not still not master in this area, you will find some problem. Okay. In this case, we already in this example is already give you the information with the load acting 2 kilonewton, but in during test, definitely you need to find what the value based on the some information, the load, the acting, something like that. Okay. 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 Next. Okay. Okay. Next is about okay. Another example of calculation. Example lot of calculation. Okay. Things need to give you some. Okay, another example is okay. Let's say we have Okay, another example is on the second equation. Second equation. Okay, this one. Okay. Okay, another example is, let's say, the other way around. The other way around, let's say you have this shaft, shaft, and you have a load. Okay, you have a load. Okay, let's say this is O and this is C. Okay, and then you have this area. Okay, let's say we have a radial load. Okay, radial load. Okay, 3550 Newton. Okay, and then we have axial load. Axial load. Okay, we have axial load. Let's say 2000. 2000. Okay, from your from the okay, imagine that just okay, we have a shaft and then we have we have the gear. Gear. Okay, from this problem. Okay, we have a desire. We have a radial load. Okay, radial load. Okay, and then we have thrust load. Thrust load. Okay, thrust load. Okay, so means that it's reflect on these okay, it's reflect about this is reflect about combination of radial and thrust load. Radial and thrust load. Okay, so we need to use this equation Fe XIVF in this one. Okay, in our main equation, which is this one. We need to change this FD to the F, this one. Okay, so for the case of this radial and thrust, okay, so for the load F, we need to use equation this one. We need to use equation XI V F sorry R plus yi fa. So what is xi? Okay, xi is radial load factor. Radial load factor. Xi radial load factor stable 72. Stable 7.2. Okay, what is it? Okay, where is 7? Stable 72. Okay, this is table 72. Okay, table 72. Okay, we need to find the value of okay, before that we need to know what is fa divided by co. Okay, we have to know what is the fa divided by co. Okay, we need to know what is fa divided by co. Okay, what is co? Okay, all right. Co, as I told just now, if you refer to the catalog, okay, this is co. CO is the basic load rating, okay, for the static, and C10 is a dynamic. Okay, let's say, let's say the question is what is expected life, life at C, at C. C means that at this site lah, at this site, okay, at this site with the radial and thrust load, and then the question is what is expected life means that if we use the bearing, means that in this case, case number two, in this problem number two, okay, we know uh, what is the bearing, what is the bearing information that you use. Let's say, for example, our bearing, I should give you the chart, but never mind. See, okay. Okay, let's say, okay. Back to question number just now, okay. Normally, there will be information about the bearing, okay. Let's say similar to this, you have no the diameter, diameter, print screen. Okay, the basic. Okay, let's say basic, okay. Diameter 30, 30. 30. This one is 62. Okay, this one 16. Okay. The value of C10 is 20.3. Okay, the value of CO is 11.2. Okay, and then this is some value lah. Okay. This the important is about the diameter. What is the diameter? And also what is the value of this one? Okay. So there be definitely there will be a code lah, code. Basically normally there will be a code. Okay. I defect again. Sorry. Okay. So let's say just now the bearing code. Let's say this is bearing here. The code is bearing is XX. Okay. And then with this code bearing the diameter which is 30, and then the value of C10 and CO is this one. Okay. Okay. The value of C10 and CO is given from the catalog. Okay. This one. Okay. So, okay, in our case, remember in our case just now is case number 2. We know the bearing, and then we know all the load, radial and thrust load. Okay. We want to know what is the expected life. The life means that just now lah. Just now we set 5,000. But if we use this is another case. Another case that we select the bearing. We know the value C10, CO from the catalog. From our calculation, we know the radial and thrust load. And then how long expected life? How many hours? How many thousand hours before fail? Okay, so to solve, we need to use the another equation, which is this one. This one. Okay. Okay, to solve, we need to go to table 7.2. Table 7.2 asks value of FA divided by CO. FA divided by CO. Okay. So in our case, FA is a thrust, thrust load at C, point C. So its value 2000. CO, our value CO just now. CO, sorry, CO. Okay. This one, CO, 11.2. CO is 11.2. So what is the value? Okay, hold on. Okay, I think, okay. Sorry, okay. It's a mistake here, maybe. 2000 Newton, CO just now. Okay, so 11.2, 1, 2, 3, 11.2, Betul. Newton. Betul tak, 1, 2, 3, So, berapa? Dapat? Berapa value? Okay, so I think yes, 1.78. Okay, thank you Ladin also. Okay. Okay. All right. Then we get the value of okay, then we refer 0.17 0.17 0.17. Okay. Then next step is we have to know okay, the next step we need to find VFR, VFR. 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 Okay, what is V? In our case, what is V? Okay, what is V? I also forgot. What is V?
Rotation factor.
Sorry?
Rotation factor.
Okay, rotation factor. Which page number? Okay, this one 20 20 Okay, rotation factor. Alright. Inner ring rotate, outer ring rotate, safe line bearing. Which one? Okay, so okay, rotation factor is defined in our design of bearing. In our design of bearing. So in our bearing, normally our shaft will go inside. Okay, so the rotate in this case will be inner ring rotate lah. This one. In our case, definitely this area that rotate lah. This area rotate. So that's for this is inner. Inner ring. Inner ring rotate. So V equal to 1. Alright. So then we calculate V1 our FR. FR. What is FR? Okay, radial load. Radial load. FR, FA, radial. Okay, this is FD, radial. Radial load. How come I use FD? Desire. Okay, desire. Okay, desire radial load. Okay, in our case, radial load. Okay, FR radial load. Okay, this is a radial load. This is as a radial load. Radial load. Okay, so 3550 lah. Okay. So then, what next step? Refer to 7, page 72. Okay. FAV divided by, okay, and then FA divide VFR. Okay. All right. So V thrust. Thrust just now 2000 Newton divide by VFR. Okay, VFR is 3550 Newton. So what's the value? Okay. Okay, what is the value of E? Okay. Can you define E? So just now berapa nilai ni? 0. FACO 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 0.17 7x6. 0.17 0.17 17x6 17x6 means that 1770. So it's between, so it's between 17 and 0.28, 0.34 and 0.38. Okay. So interpolation, okay, definitely. Okay, from here E is somewhere in between, so roughly is about 0.3, let's say 35. Okay. So in this case, FA, VFR, okay, 0.5, 0.35. So it's bigger than value of E. It's bigger value than E. So therefore, okay, we need to use, because of this, we need to use this value, x2, y2. X2, y2. Okay, so we are here just now. 0.78. Okay, so this 0.74. Okay, so our value here x2, y2 is somewhere 0.56, 0.556. Okay, and 131 and 1.31, 1.15. Okay, 1.15. So F okay, x2, x2. So you need to find the interpolation, interpolation for the case of this one. For the case of you need to find the interpolation. This one, this interpolation, this interpolation. Okay. So x2. So x2 definitely 0.56. VFR just now. Okay, VFR 3550 plus Y, this one, let's say this is exact. So FA 2000. So you got this F. Okay, 5 minutes for you to calculate. Anybody lost because involve too many screen in my calculation? Uh, which one? This one 0.5634 eh? Uh-huh. Okay, so this okay this equation, this is referring to the this one. Kan? Okay, this is so in our case should be I is number 2, Y number 2. It's correct. Betul tak? And because of just now we do this we are doing this comparison. We calculate okay this value, this one, okay, this E, this one, this one. So from here 0.56 is bigger than 0.35, bigger than 0.35. Therefore, if referring to this figure, okay, xi is referring to either I referring to either number one or number two. Okay? That's why in the step we need to know this FA VFR is less or bigger than E. From our calculation is bigger. That's why in our case the I is become number 2. Is it clear? Okay. Okay, try to solve that one. Okay, F. Okay. All right.